Hi, welcome to the video solution for Edexcel IAL Physics. This is Edexcel IAL Unit 5, January 2021 paper. So let's start. Question number 1. A mixture of oxygen gas and nitrogen gas is kept at room temperature. Oxygen molecules are more massive than the nitrogen molecule. So they have the same temperature. Temperatures are same. But masses of course are different. Oxygen molecules are more massive. Which of the following is correct? The mean velocity of oxygen molecule is greater than the mean velocity. Remember, mean velocities of all gases, when we talk about mean velocity, regardless their mass, regardless their size, mean velocity of all gases are always 0. So there's no chance of anyone is greater or less. So option A is wrong. The mean speed of the oxygen molecule is same as the mean speed. No. Mean speed, when you talk about mean speed, oxygen molecule is heavier. So speed is a scalar quantity. Then you can think speed is half mv square. So oxygen is heavier, so mean speed is not the same. It should be more. The mean kinetic energy of the oxygen molecule is greater than the mean kinetic energy. No. Remember, they are at the same temperature. So basically, when you see the kinetic energy and the temperature, so average kinetic energy is proportional to the absolute temperature. So kinetic energy, mean kinetic energy or average kinetic energy is proportional to the temperature, and they have a same temperature. That means they should have a same mean or average kinetic energy. So option must be D, because oxygen molecule mean kinetic energy of oxygen is the same as the mean kinetic energy of nitrogen, because kinetic energy or mean kinetic energy especially depends on absolute temperature, not the masses. So they have a same average kinetic energy or mean kinetic energy. Option is D. Scientists believe the sum of the mass of our universe consists of dark matter. A typical question about the property of a dark matter. Remember, the dark matter is something that we don't know anything about the dark matter. The reason is we cannot detect dark matter. In space, we can detect object through radiation, whether radiations are absorbed by something and radiations are emitted by something or some object. So due to absorbed or emitted radiation, then objects are detected in deep space or in space. So dark matter is something that does not interact, or basically does neither absorb nor emit electromagnetic radiation. So it absorbs? No, it does not absorb. It emits no electromagnetic radiation. This is the correct option. It exerts no gravitational force. No, it does apply basically gravitational force. That's why we know that there something exists. That's what we give the name dark matter. So dark matter apply gravitational force, and we have a calculation. It is a form of antimatter. No, there's no relation of dark matter of antimatter. Antimatter is entirely different thing. So option C and D. Option is basically B. It emits no electromagnetic radiation. I told you dark matter neither absorb nor emits electromagnetic radiation. So option is B. Question number 3. The penetration of matter by radiation depends on the ionizing power of the radiation. Which of the following statement is correct? Alpha particles are weakly ionizing. No, alpha particles are strong ionizing. Alpha particles are highly ionizing. This is correct. So they only travel a few centimeters. Yes, this should be the option. Let's check other. Gamma radiation is highly ionizing. No, this is wrong. Gamma are most weak, weak ionizing, weaker than even beta. Gamma radiation is weakly ionizing. Yes, this is fine. it is not very penetrating. No, this statement is wrong. So this statement correct, this is wrong. Gamma radiation highly ionizing, wrong, but it is highly penetrating. Yes, this is correct. Alpha particle highly ionizing, correct. They travel only few centimeters. This is correct. So option is B. A metal bar is heated then allowed to cool. The wavelength lambda max at which peak radiation emission occurs is determined. Which of the following statement is correct? Lambda max decreases as the metal bar cools. No, if you see, this is all about black body curve. So the black body curve is, this is the wavelength, and you have a curve that increases, and then, so this is basically the value of lambda max or lambda 1 max at temperature T1. If you increase the temperature of the same body at some higher temperature, so the black body curve follows this shape, something like this, and this is the peak value at temperature T2. So T2 is greater than T1, and this is the lambda max, and clearly you see that the lambda max, this is lambda 2 max, lambda max at temperature T2. So as temperature increases, the maximum wavelength of maximum radiation is decreased. They are saying metal bar cools, meaning temperature decreasing. So lambda max decreases. No, if temperature decrease, lambda max should increase. This is wrong statement. Lambda max increases as the metal bar cools. Yes, lambda max increases as the metal bar cools. Lower the temperature, higher the value of the lambda max. So lambda max is increasing for as temperature decreases. So this is the correct option. And let's see other two options. Lambda max increases as the metal bar is heated. No, I told you lambda max is decreased as temperature is increased. So this is wrong statement. Lambda max stays constant as, so yes, it does not stays the constant. It must change. In fact, decreases. So this is wrong. Only correct option is B. So B is your option. Question number 5. A car is driven along an uneven road. This forces the car into vertical oscillation over time. The energy of oscillation of the car increases by factor of 4. Energy of the oscillation is increasing by factor of 4. The amplitude of the oscillation increases by factor. Remember, the kinetic energy E is half of k x square, where x is basically nothing. This is oscillation amplitude. So for total energy, this x is nothing but amplitude. So if you wish, you can rewrite this equation. E is equal to half of k amplitude square. So basically energy depending on square of the amplitude, or amplitude depends upon square root of the energy, and energy increased by factor of 4. So if energy is increased by factor of 4 times, so square root of 4 is 2. So amplitude is increased by factor of 2 times. So option is C. Question 6. The star Vega has a luminosity 5 times the luminosity of a star Altair. The distance of Vega from the Earth is 1.5 times of distance of Altair from the Earth. The intensity of radiation received on the Earth from Vega is IV, and from Altair is IA. We need to find the ratio of IV upon IA. So intensity I in general is luminosity divided by 4 pi d square. So if you write this expression in terms of IV and IA, so remember IV is given in terms of IA, so we take intensity of IA as 1 because we are taking ratio. So intensity depends on luminosity and the distance, so ignore this 4 pi. So IV upon IA can be written as, watch carefully, IV. So luminosity of Vega is 5 times divided by 4 pi is constant, I am ignoring. D squared, distance of the Vega, is 1.5 times. So, but this is D square. So 1.5 square divided by intensity of the Altair, which is 1. So overall 5 divided by 1.5 square, and you solve this equation, and then you can have 2.2. So your option is C. A small satellite of mass 245 kg is orbiting the Earth. The radius of the orbit is equal to twice the radius of the Earth. The weight of the satellite in its orbit is about, this is the Earth and this is the orbit. This radius is double of the radius of the Earth. This is the satellite, and you need to find the weight here. So weight depends on W equal to mg, and this g is not 9.8. This is g dash, which is gravitational field strength at that position. We need to figure out this g dash. So basically g depends on two factors. G dash is gm upon r square. This is general formula for, and if you need to find whether you are talking about any position, this g and the mass, these are the constants. So basically g, gravitational field strength, is proportional to the square of the distance. So at this point, basically g dash at that position is 1 upon r square. So this is double, 1 upon 2 square of the value of g. This is the gravitational field strength at double of the radius. So 1 upon 2 square of g. G is 9.8. So of course g you can find, and then you can do is 1/4 of the g. So 1/4 of the g, 9.8. So weight would be W is equal to mg, which is 245. It is a mass into g dash, and g dash is 1/4 of 9.81, and W would be equal to 600, around 600 point something. So option is B. Question number 8. Two stars X and Y have the same surface temperature. X, same surface temperature. Okay, T is same. X has a radius of 25% larger than the radius of Y. So Rx is equal to 25% larger, and 1.25 times of radius of Y. This is 25% larger. So 1.25 of Rx. Yes. The luminosity X is Lx, luminosity Y is Ly. What is the ratio? Again, a typical question of finding ratio of luminosity. So luminosity in terms of temperature, according to Stephen law, luminosity is 4 pi r square into T to the power 4. Remember, they have a same temperature, so nothing to do with the temperature, and 4 pi constant. So you can say that Lx upon Ly. So Lx divided by Ly. So again Ly you can take, so luminosity only depends on the radius. So you can say that luminosity of X is 1.25 of Ry square divided by Ry square. So 1.25 and ry square gets cancelled and you square 1.25, so answer will be 1.5625, so 1.6. Option is C. Question number 9-10 refers to the following information. The graph shows how acceleration a varies with time t for an object performing simple harmonic motion. So this is acceleration time graph given from origin 0 at t equal to 0. We have 0 acceleration. 4 graphs of quantity plotted against time are shown below. The scale on the x-axis is the same for each graph, so time axis is same. Which graph shows how displacement of the object varies with time? So in order to understand the relation of graph, there are 3 graphs: position time graph, velocity time graph, and acceleration time graph. So if you see, you have an object. This is the mean position, this is the mean position or equilibrium position, and this is extreme A. This is the next extreme, opposite direction, A dash. So I am considering this is the positive direction, right side, and this will be automatically the negative direction. Or you can switch, you can flip your direction, it's your choice, but generally I take generally we take right direction as a positive, left direction is negative. So now you know that for simple harmonic motion, acceleration is proportional to the displacement of the object from the equilibrium position and always acts in opposite direction. So acceleration always opposite direction as that of the x. So x at the start acceleration is 0. That means acceleration 0, so displacement will also be 0 because they are proportional. So if acceleration is 0 here, then displacement must be 0. So you can ignore option B and C immediately. So B and C cannot be of your options for 9th because you need to find displacement time graph. So it must start, displacement must start from 0. So either A or D, both are starting from 0. But because they are in opposite direction, so they are always out of phase. Now you see that acceleration graph is going down. That means displacement graph, corresponding displacement graph must be in opposite direction, so it should be going up. So your option is A. Remember, displacement time graph always in opposite direction because they are always out of phase because of the opposite direction. So your option must be A. This is the relation, if you wish. This is additional graph. So clearly the blue one or the black one is displacement time, and the green one is acceleration, and this is the velocity time, because next graph, question number 10, is a velocity time. So you can imagine, you can compare this. If you wish, you can take a screenshot or sketch it in your notebook. This is acceleration starting from origin and going down, and on the acceleration graph, this is the position you can imagine, and acceleration is going down. Look at the corresponding displacement time, it is going up. That's why option is A. Similarly, velocity time graph. So velocity time graph, if your acceleration is 0, so here velocity will be maximum. So look at that, this is going down, and velocity is starting from the corresponding time. This is the velocity time and going in this direction. So if you compare that, your option cannot be A and D, of course. For 10 it must be either B or C, but the direction says it should be C, like this. So option is C for your part 10. So for 9 it is A, for 10 it is C. Question number 11. The Earth is 9.3 times more massive than Mars. The gravitational field strength at the surface of the Earth is 2.6 times greater than the surface of the Mars. Calculate the mean radius of the Mars. Mean radius of the Earth is given. This is 2-mark question. You can do it directly if you know the relation of gravitational field strength, but I am deriving the whole formula. If you wish, you can do that. Otherwise, you can skip some steps. So you know that the gravitational field strength in general is G is equal to Gm upon R square. M is the mass of the main planet or star or whatever from which we have a gravitational field strength, and R is the distance from the center. This formula, if you wish to write for Mars, you can write as gravitational field strength of Mars would be equal to capital G, which is constant everywhere, and mass of the Mars divided by radius of the Mars is, and that's what we need to find. Rm, we need to find radius of the Mars. Now gravitational field strength of the Mars is gravitational field strength of the Mars is 1 upon 2.6 times, because Earth is greater, 2.6 times greater. That means Gm is 1 upon 2.6 times of the Earth. So Gm is, you can say 1 upon 2.6 times of G. Capital G is constant. Mass of the Mars, and mass of the Mars is 9.3 times, or sorry, this 9.3 times is the mass of the Earth. Earth is this much heavier. That means mass of the Mars is 1 upon 9.3. So into 1 upon 9.3 times of mass of the Earth divided by radius of the Mars square. That's what we need to find. So you know that this G is the gravitational field strength of the Earth. This G you can write 1 upon 2.6. This G, this you can write as for the Earth. So G, mass of the Earth divided by radius of the Earth square equal G 1 upon 9.3 mass of the Earth divided by radius of the Mars square. Clearly mass of the Earth cancel, capital G cancel. So 1 upon 2.6 into 1 upon RE square is equal to 1 upon 9.3 Rm square. You can do your maths, you can make Rm as a subject. So if you do your maths, and Rm square is equal to 2.6 divided by 9.3 times of R I guess Rm square oh yes, Rm square is equal to 2.6 times of Re square divided by 9.3. Now you have Re, which is 6.37. Substitute this value and then take the square root. So Rm would be equal to 3.37 10 to the power 6 meter. This is the radius of the Mars. These are additional steps. Some steps you can skip if you wish. You can directly use this formula to just change the value here, and then you can find Rm directly. It's up to you. Question number 12. A portable electric heater with a power of 280 watt is used to boil water for a hot drink. The heater is placed into a cup of water. There is a 165 gram mass power of water in the cup. The initial temperature of the water is 12.5 T1. Assume that all the energy from the heat is transferred to the water. The heater is used in London, where the boiling point of water is 100 T2. Show that time taken for the water to reach the temperature is about 220. A specific heat capacity C of the water is given. So you can directly use the formula delta E energy is equal to MC delta T. This is the formula for a specific heat or energy given. This delta E is energy given or supplied to heat the water. In this case, this delta E you can write as power into time. So energy is P into T is equal to MC delta T. So you can find time T is equal to MC delta T divided by P. That means mass is 165 gram. You need to convert into kilogram. 0.165 times the specific heat, 4190 times delta T is because we are finding delta T, you don't need to convert into Kelvin, so 100 minus 12.5 divided by power 280, and then the power will be, the time T would be equal to 216.04 second. That's how you can find time. Part B. The same heater is used in La Paz, the world's highest capital city, where the boiling point of water is 87.7. It boils little early. That means less heat causing water to boil. The mass and initial temperature of the water are the same, and the heater is used for the same time. That means we keep turning on heater for the same amount of time, and then heat keeps going in. Calculate the mass of the water converted to water vapors as the water boils. Remember, water is boiling at 87.7, and we keep giving heat. That means the giving heat is going to do two things. Number one, some part of the giving heat will be used to boil the water, and rest of the heat is going to use to convert water into steam or water vapor or change of a state. So this is just for your information. No need to write in your reference in your working. So you can say that given heat is equal to energy to raise the temperature to boil, reaching temperature 87.7 plus rest of the energy, because we are keep giving heat till this time. So rest of the energy now is being used to change the state, from liquid to gas. So of course this giving heat is you can say heat is P into T. Let me write here. PT is equal to energy to boil the water. So you can say that MC delta T. This is the amount of energy that is going to boil the water, reaching temperature 87.7 plus. Now rest of the energy is going in to change the state, and state change, the energy is M dash into L. L is latent specific heat. This is latent heat. And this is m dash is the mass that converting into vapor. That's what we need to find. Basically, we need to find this m dash. So now let's make m dash as a subject. If you do m dash as a subject, and I am just saving time, make m dash as a subject and you substitute the number. So m dash is equal to pt minus mc delta t. So pt is 280 times time. Time is 216.04 minus mc delta t. M is initial mass is same, 0.165 into specific heat, which is 4190 given here. Delta T, and delta T is change in temperature from 12.5 to 87. So this is 87.7 minus 12.5, and then divided by latent heat of vaporization. So latent heat of vaporization is 2.29 into 10 to the power 6. Once you solve that, mass of the liquid water or water converting into vapor is 3.71 into 10 to the power minus 3 kilogram. Question number 13. The SI system of unit was established in 1960. There are 7 base units in the SI system, including the meter, which is the base unit of length. Give the SI base unit of energy. Remember, it's a typical question you have done in your AS. Energy unit is joule, but this is SI unit, not SI base unit. This joule is, you can, if you memorize, if you remember, you can directly write answer. But if you don't remember, so joule is equal to Newton meter, and Newton is kg meter s minus 2. Mass into acceleration into meter, and meter square. So you directly write kg meter square s minus 2. This is the SI base unit of energy. Joule equal this. In 17th century, Huygens suggested that the unit of length should be defined by the length of a second pendulum. This is a simple pendulum that takes exactly 1 second to swing from one extreme to other. Calculate the length of the simple pendulum that swings from one extreme position to the other in 1 second. So basically, if you recall, this is the simple pendulum equilibrium position. This is one extreme and this is another extreme, and they are saying that this is the pendulum that oscillate from one extreme to another extreme, this one-sided, in 1 second. That means if I ask you, if you think what about the time period, time is time for one oscillation. One oscillation is pendulum starts oscillation from A, goes to A dash, and then return. So basically time period T is 2 seconds, and this is the time period for second pendulum. So we need to find the length of this pendulum, and in order to find the length, you should remember, you should memorize, or you should know the formula for time period for simple pendulum, any length. So time period T is equal to 2 pi L upon G. You know that we are talking about second pendulum, and the time period is 2 seconds. Remember, they are saying 1 second is for the time for only half of the swing from one extreme to another extreme, but the time period is to return to the same position. So time period is 2 seconds. This 1 second is half of the time period. That's why. So now you need to find length, and T is 2. So make L as a subject. Remove the square root, so you have a square on both sides. So you have a T square. These are additional steps. If you wish, you can do, otherwise you can skip. T square 4 pi square L upon G. So L is equal to GT square divided by 4 pi square. Substitute the value, 9.81 into 2 square divided by 4 pi square. Once you solve that, then length would be equal to 0.994 meter. 3 significant figure, that's why I'm writing in 3 significant figures answer. Suggest a disadvantage of basing the meter on length of the second pendulum. Clearly, if you see the formula, the length, because second pendulum time period always remains 2 seconds. So the length of the pendulum as per formula, yes, so length of the pendulum depends upon G. If you see that formula, L equal to G by, so L equal to G So you see that the length, yes, length depends upon G. Length is proportional to G, and you know that this value of G, gravitational field, is strength, and it keeps changing from place to place. That means the length of the second pendulum keeps changing. So we can not use the second pendulum as a base unit to define the length. Question number 14. Xenon gas is used as an anesthetic. The gas is stored in a cylinder under pressure. A cylinder with a volume of this V contains 7.5 10 to the power 24 atoms. These are N. The gas in the cylinder is at a temperature of 20 degree. This is temperature T in Celsius. Calculate the pressure. So number of molecule, volume, temperature given. We need to find pressure. Typical question. We know that PV is equal to NKT. Remember, here we are using temperature, not the change in temperature. That's why this Celsius should be converted into Kelvin. So we need to find pressure. Pressure is equal to NKT upon V. And is the number of particles 7.5 into 10 to the power 24 into K. K is Boltzmann's constant. It is given in your formula sheet. 1.38 into 10 to the power minus 23, or you can memorize, and into T. T is absolute temperature. So T is 20 plus 273. And then divided by the volume, 6 into 10 to the power minus 2. So pressure would be equal to 5.05 into 10 to the power 5 Pascal. Gas is removed from the cylinder. The temperature of the gas decreased by 5 degree. Remember, don't confuse with that statement, decrease by 5 degrees Celsius. Some students think that now temperature is 5. No, before temperature was 20, it has decreased by 5. That means new temperature will be 15, not 5. And the new pressure is this, because some gas has been removed and temperature decrease, and of course the new pressure is this. calculate the percentage of original number of gas molecule remaining in the cylinder. So we need to find the percentage of the remaining molecule. So first we find how many molecules or how many particles remains at that temperature after removal. So we use the same formula, and then we say that number of particles N is equal to PV upon KT. So P is the pressure, which is the new pressure 4.5 into 10 to the power 5 into volume, because the container is same, so volume will be same. So 6 into 10 to the power minus 2 divided by K is constant, Boltzmann constant 1.38, 10 to the power minus 23 into temperature. T is absolute temperature, which is not 5 degree, it is 15 degree. This T would be equal to 15 plus 273, and then when you solve this, you have a number of particle N is equal to 6.8 into 10 to the power 24. These are new particles. Now you can find the ratio or percentage change. So you say that N upon N naught into 100. That's what you need to do. Of course, power of 10 is same. So 7.5 divided by 6.8 times 100. Because 10 to the power 24, 10 to the power 24, they will be cancelled. So when you solve that, you have answer 90.6%. Question number 15. A student investigated the absorption of gamma radiation by iron. She placed a gamma source in the holder and set up a GM tube a short distance away. She placed thin sheet of iron between the GM tube and the source as shown. So we have iron sheet here, source emitting gamma radiation, absorption in iron sheet, and then received in GM tube. So this is, you can imagine, this is the radiation going and received, and we have a count rate. The student used 5 different thickness of iron and determined the count rate for each thickness. The count rate with no iron sheet in place is R0. This is original count rate. After passing through an iron sheet of thickness X, the count rate R is given by the equation R is equal to R0 e to the power minus mu X, where mu is some constant. The student used her data to plot a graph. Remember the equation R is equal to R0 e to the power minus mu X. R0 is the original count rate without any sheet before absorption, meaning R is after absorption. So this is the data plotted by the student. We have a graph of ln R against thickness X in centimeter. The student used the gradient of the graph to determine a value of mu and used this to estimate the half value thickness for the iron. This is the thickness of the iron that would reduce the count rate to R0 by 2. The student used a source that emits gamma rays of energy 1.1 million electron volt or mega electron volt. Deduce whether the data of the student obtained confirms this energy value. Half value thickness of 1.1 milli electron volt. Forget this gamma rays source is 1.5 centimeters. So we need to confirm whether this data supports the value or the relation or this thickness mainly. So basically we need to find thickness X or half thickness so that we can compare. So we can compare the half thickness with that value. So now First of all, this is 6-mark question. What is the idea? We have a formula R is equal to R naught e to the power minus mu x. And you know that you can use your mathematics or concept of log to rewrite this equation as ln R is equal to minus mu x plus ln R naught, ln R naught. And this equation can be compared with y equal m x plus c. That means m is the gradient, which is equal to minus mu. So we find the gradient of the graph. From this graph we find the mu, and we use this mu to figure out the value of x from this original equation, and we compare x with this. So let's find the mu. So gradient m is, we choose 2 points. So we choose this point, I guess, yes, and this point. This is the best. We can choose this point as well. It's fine. It's up to you. Choose any 2 points, but 0.5. So 0.5 comma and 6.5 and 6.6. Yeah, 6.6. And this is 3.5 comma 5.1, 2, 3, 5.1, 5.2. These are the 2 points. Now you can use these 2 points to find mu, or the gradient. So gradient would be equal to y2 minus y1. So 6.6 minus 5.2 divided by x2 minus x1, 0.5 minus 3.5. So the gradient would be equal to minus 0.466. Minus 0.466. This is the gradient, which is in fact mu. So mu is equal to 0.466. Minus get cancelled. So mu is 0.466. Now at half thickness, if at x is equal to half of the thickness, not half of x but x of half thickness, so the count rate r would be half of the original value. This is the relation, r equal to r naught upon 2, and you can substitute this here. So r is r naught upon 2 is equal to r naught, I am changing this equation, r naught e to the power minus mu we have found. I can put minus 0.466. I can do it later, x of half. And now r naught cancel. You use your maths, you know that this is 1 upon 2 is equal to e to the power minus mu x half, and you take log. So you can say that minus ln 2 is equal to minus mu x half. This is subscript. Minus get cancelled. So x half is equal to ln 2 upon mu, and then ln 2 upon mu is 0.466. So x half is equal to 1.47 centimeter. Clearly this is 1.5, this is 1.47. So yes, the data confirms. The data confirms. the value, the energy value, of the gamma radiation. You can write comments here. Thank you very much. I hope you understand. If you have any doubt, let me know in the comment section. I will try to clear your doubt as soon as possible. Thank you very much. Have a nice time.